I welcome you all in EPSEC's online sport program for class 9 subject physics. This is third video lecture of chapter number 4, turning effect of forces. So at the end of this lesson you will be able to define the term axis of rotation, torque or moment of the force, line of action of a force, principle of moment, and you can define the term center of mass and center of gravity. Before moving further, let us take a quick recap of our previous knowledge in which we discussed about resolution of forces, decomposition of a force into two mutually perpendicular components is called the resolution of that force. Second topic is determination of a force from its perpendicular component. As we know, a force can be resolved into two perpendicular components. Its reverse is to determine the force knowing its perpendicular components. And the third topic is torque or moment of a force, and a torque is defined as the turning effect of a force is called torque or moment of that force. Axis of rotation. Consider a rigid body rotating about a line. The particles of the body moves in circle with their centers, all laying on this line. This line is called the axis of rotation of the body. Forces that produce turning effect are very common. Turning pencil in a sharpener, or water tap, turning doorknob, and so on are the some examples where a force produces turning effect. So what is meant by axis? The axis is defined as it is a real or imaginary line on which something rotates, or a straight line around which things are arranged. For example, axis is an imaginary line running through the earth on which earth rotates. So what are the examples of rotation? Basically, rotation is the process or act of turning around something. An example of rotation is the earth orbit around the sun. Another example of rotation is group of people holding hands in the circle and walking in the same direction. Turning effect of a force is called torque or moment of the force. Here a question arises why the handle of a door is fixed near the outer edge of a door. So when we open or close a door more easily by applying a force at the outer edge of the door rather than near the hinge. The location where the force is applied to turn a body is very important. Let us consider factors on which torque or moment of force depends. You might have seen that a mechanic uses a spinner to loosen or tighten a nut or a bolt. The spinner have long arm helps him to do it with greater ease than the one having shorter arm. It is because the turning effect of the force is different in the two cases. The moment produced by a force using a spinner of longer arm is greater than the torque produced by the same force but using a spinner of short arm. There is a slightly difference between moment and torque in mechanics, whereas in physics they signify the same thing. Both have the same unit like Newton meter. Torque is a movement force whereas moment is a static force. Torque is used where there is rotation involved, whereas moment is used where there is no rotation. Is torque is energy? Note that the SI unit of a torque is Newton meter, which is also a way of expressing a joule. However, the torque is not energy, so to avoid confusion, we will use the unit Newton meter, not joule. Energy is a scalar quantity, whereas the torque is a vector quantity. Mathematical form of torque is tau is equal to R cross F, whereas R is the moment arm and F is the force. Remember, R, torque, and F are all vector quantities. Next is line of action of a force. So the line along which force acts is called the line of action of the force. As you can see in this figure, line BC is the line of action of the force. In physics, the line of action of a force is a geometric representation of how the force is applied. It is the line through the point at which the force is applied in the same direction as the direction of the vector or force F. Next is a moment arm. The perpendicular distance between the axis of rotation and the line of action of the force is called the moment arm of that force, and moment arm is represented by distance L. The torque or moment of a force depend upon the force F and the moment arm L of the force. Greater is the force, greater is the moment of the force. Similarly, longer is the moment arm, greater is the moment of the force. Thus, the moment of the force or torque is determined by the product of force and its moment arm L. Mathematical, it can be represented as torque is equal to force into L means moment arm. SI unit of torque is Newton meter, and a torque of 1 Newton meter is caused by the force of 1 Newton acting perpendicular to the moment arm 1 meter long. Next topic is principle of moments. A body is balanced if the sum of clockwise moments acting on the body is equal to the sum of anti-clockwise moments acting on it. A force that turns a spinner in the clockwise direction is used to tighten a nut. The torque or moment of the force produced is called clockwise moment. On the other hand, to loosen a nut, the force is applied such that it turns the nut in anti-clockwise direction. The torque or moment of the force produced is called anti-clockwise moment. A body initially at rest does not rotate if sum of all the clockwise moment acting on it is balanced by the sum of all anticlockwise moment acting on it, and this is known as the principle of moments. As principle of moment states, a body is balanced if sum of clockwise moment acting on the body is equal to the sum of anticlockwise moment acting on it. Next topic is center of mass, and center of mass of a system is such a point where an applied force causes the system to move without rotation. The center of a mass of a system is a hypothetically point where the entire mass of the body is supposed to be concentrated. It is observed that center of a mass of a system moves as if its entire mass is confined at that point. A force is applied at such a point in the body does not produce any torque, means any rotation in it. The body moves in the direction of net force without any rotation. Now consider a system of two particles A and B which is connected by a light rigid rod. Let the force applied at particle A or near the particle A, the system will move, but as well as the system will rotate. And if we applied force on heavier particle B, at this point the system will move as well as rotate. But if we applied a force near the heavy particle, as you can see, if we apply a force on this point, point O, in this case the system will move without any rotation. So center of a mass of a system is such a point where an applied force causes the system to move without any rotation. Now consider this system, and we consider three cases in a system. In first case, let a point O is a point anywhere between A and B such that the force F is applied at point O. If the system moves in the direction of applied force without any rotation, then point O is the center of the mass of the system. In this case, if we applied a force near the lighter particle, the system moves as well as rotates. And in this case, if we applied a force near the heavier particle, in this case the system will also move and also rotate. Next is center of gravity, a point where the whole weight of the body appears to act vertically downward is called center of gravity of that body. The center of gravity of an object is the point at which weight is dispersed and all sides are in balance. A human's center of gravity can change as he takes on different position, but in many other objects its fixed location. Center of a mass is the point at which the distribution of mass is equal in all directions and does not depend on gravitational field, whereas the center of gravity is the point at which the distribution of weight is equal in all directions and does depend on gravitational field. As we know, a body is made up of large numbers of particles. Earth attracts each of these particles vertically downward towards its center. The pull of the Earth acting on a particle is equal to its weight. These forces acting on the particles of a body are almost parallel. The resultant of all these parallel forces is a single force equal to the weight of the body. A point where this resultant force acts vertically towards the center of the earth is called the center of gravity G of the body. It is useful to know the location of the center of gravity of the body in problems dealing with equilibrium. Center of gravity of a body is a point where its entire weight is assumed to act vertically downward. The center of gravity of objects which have symmetrical shape can be found from their geometry. For example, the center of gravity of a uniform rod lies at a point where it is balanced. So center of gravity of a rod is lie at the center because a rod is balanced from its center. Center of gravity for a uniform sphere or a rectangular sheet is the point of intersection of its diagonal. We will consider the center of gravity of an irregular shaped. A simple method to find the center of gravity of a body is by using a plumb line. A plumb line consists of a small metal bob supported by a string. When the bob is suspended freely by the string, it rests along the vertical direction due to its weight acting vertically downward. In this state, center of gravity of the bob is exactly below its point of suspension. To find out the center of gravity of an irregular shape, we consider a piece of cupboard, make holes A, B, and C near its edge. Fix a nail on a wall, support the cupboard on the nail through one of the hole, let it be A, so that cupboard can swing freely about A. The cupboard will come to rest with its center of gravity just vertically below the nail. Vertical line from A can be located using a plumb line from the nail. Mark the line on the cupboard behind the plumb line. Now repeat it by supporting the cupboard from the hole B. The line from B will intersect at a point which is known as G. Similarly, draw another line from the hole C. Note that this line also passes through G. It will be found that all the vertical lines from holes A, B, and C have a common point, which is G. This common point G is the center of gravity of the cupboard. This is all about today's lecture. Thank you for listening.